A chance encounter with a flock of seagulls results in a catastrophic engine failure, which the engine manufacturer says simply shouldn't happen. In a desperate effort to save their reputation, what they finally uncover will come as a huge surprise to all concerned, and ultimately result in the improved testing and redesign of large turbofan engines. This is the complete story of Overseas National Airways Flight 032. With the Wright flyers taking to the skies of North Carolina on the morning of December 17, 1903, man made his very first tentative steps into the realm of powered flight. From that day forth, pilots have continuously sought to safely share those very same skies with their feathered avian counterparts, with often mixed results. On occasions where the two inadvertently cross paths, the resultant incident report is officially termed a bird strike, although most encounters are exactly that, inadvertent and accidental. Interestingly, the very first recorded bird strike was anything but. An entry in none other than the Wright brothers' own diaries recounts an occasion where Orville was flying circles over a cornfield near Dayton, Ohio. He had apparently been chasing flocks of birds for some time before finally he hit one. The dead bird lay on the aircraft's wing for a period of time, before Orville made a deliberate sharp turn, allowing it to fall to the ground below. Sometime later, on April 3, 1912, aviation pioneer Cal Rogers, while flying a Wright's EX biplane as part of a demonstration flight at Long Beach, California, collided with a lone seagull, which became entangled in the aircraft's control cables, causing Rogers to lose control and crash into the Pacific, thereby claiming the unenviable title of first bird strike fatality. As such encounters continued down through the decades and became an ever-present if infrequent occupational hazard, little could the crew of Overseas National Airways Flight 032 have ever expected that they, on the afternoon of November 12, 1975, would also achieve yet another bird strike milestone. Having reported for duty at 10 a.m. that morning, within a few short hours they would find themselves running for their lives away from their burning DC-10, the largest aircraft to date ever to have been lost as a result of one such inadvertent avian encounter. Overseas National Airways was at the time a non-scheduled charter operator based out of Oakland, California. Its business model often centered around wet lease type contracts, whereby they provided the aircraft along with crew and maintenance, whilst the contracting airline managed all the financial aspects of the operation, such as ticket sales, marketing and the like. Of all these potential contracts, it was the annual Hajj pilgrimage flights which consistently proved to be the most lucrative. On the morning in question, the aircraft, along with its 11 crew members and 128 passengers, all of whom were ONA employees, was being ferried via Frankfurt, Germany to Jeddah in Saudi Arabia, in order to commence just such a contract, flying pilgrims from all over the Muslim world back and forth to the kingdom during the period of late November into early December. This specific contract would not only call for both the company's DC-10s to be involved, would also require the utilisation of 5 of the company's DC-8s as well, and it was largely the logistical support teams of pilots, cabin crew and mechanics behind such a mammoth operation which had formed the nucleus of the 128 passengers on board that day. In command of the flight that afternoon was 55-year-old Captain Harry Davis. Davis had already accumulated about 25,000 hours of total flight time, 2,000 of which had been obtained on the DC-10. His co-pilot for the trip was to be First Officer Raymond Carrier, aged 52. Having only recently converted over from the company's DC-9 fleet, where he had held the position of captain, Carrier had only logged a modest 450 hours on type. The third member of the flight deck crew, and seated to the rear of the cockpit overseeing the flight engineers panel, was 44-year-old Second Officer Jack Holland. His total time amounted to about 12,000 hours, having logged 2,000 hours or so on the DC-10, a similar amount of experience to that of his captain. In addition to the 3 flight deck crew, one of the 2 cockpit jump seats had been occupied by Ben Coddister, a company DC-8 pilot, who was interested in simply observing what was happening up front. Coddister had hoped to try out a newly purchased movie camera he had brought with him for the occasion, and having obtained Davis's permission, was intent on recording the takeoff out of Kennedy for his own posterity. unaware that this innocent act on his part would, from the subsequent investigator's perspective, provide an extremely fortuitous insight into the events of that fateful afternoon. ONA Flight 032 had pushed from its parking position on schedule at approximately 12:30 local, having uploaded a total of 235,000 pounds or just over 106,500 kilos of fuel. The aircraft's gross weight at pushback was just on 556,000 pounds or little over 252,000 kilos. In estimating a fuel burn on taxi of about 2,000 pounds or 900 kilos, Davis had calculated that the DC-10 would be about 1,000 pounds or 450 kilos below the runway limiting weight if it were to request a departure from runway 13 right, which at just over 14,500 feet or 4,400 metres in length was the longest at the airfield. Situated along the southernmost perimeter of the airport, runway 13 right runs adjacent Jamaica Bay for the entirety of its length, with the bay being home to numerous mud and sand flats, swampy islands and garbage dumps, all of which would have done nothing to discourage birds from roosting in the area. Indeed, on the two previous airport safety inspections conducted by the Port Authority of New York, dated September 73 and 74 respectively, the inspection teams on both occasions had made reference to the fact that the level of bird activity at the airport represented a significant potential hazard to aviation. Of significance to the fate of Flight 032 that afternoon was the fact that, although having been issued with a departure clearance from runway 13 right, the runway itself had been deemed non-conforming, in that it wasn't being used for current arriving or departing traffic. Why this should be of concern is the fact that, not being in current use, typically birds from the locality would tend to roost on its paved surface, undisturbed due to the absence of any aircraft movements. To mitigate the dangers that this would obviously give rise to, prior to releasing any aircraft for takeoff from such a non-conforming runway, it was good practice for the tower controller to firstly have a runway inspection and bird patrol carried out, thus clearing the runway of any potential conflict before being brought back into service. On the afternoon in question, however, this never happened. As the DC-10 approached the threshold of 13 right, the early morning rain showers had by now moved off the coast, although the runway itself still remained visibly wet, and so at just after 1 in the afternoon the crew of ONA 032 received and acknowledged their line-up and takeoff clearance.
Liberty 032, clear takeoff runway 13 right, surface wind 160 at 8.
Roger, Liberty 032, rolling 13 right.
As Davis applied power to the aircraft's 3 General Electric CF6 engines, the jet initially laboured under its massive weight before starting to accelerate along 13 right's paved surface. The initial part of the takeoff roll passed without incident, with the acceleration being considered normal and as expected. Then, however, as the jet passed approximately 100 knots, Davis caught sight of a significant-sized flock of birds roosting on the runway surface just up ahead. Most probably disturbed by the noise of the approaching jet, he recalled that at a guess about 100 or so birds took flight, separated and then regrouped directly in front of the DC-10 as it continued to accelerate down the length of the runway. "Son of a bitch," he exclaimed. Almost instinctively he called out to Carrier and Holland to watch the EGTs, meaning the engine's exhaust gas temperature, any fluctuation of which would be indicative of the fact that birds had been ingested, with subsequent engine damage more than likely. However, any hope he had that they might somehow manage to avoid the birds was quickly dispelled, as a cacophony of loud bangs and thuds were heard at the cockpit, as one seagull after the next violently slammed into the jet's fuselage, wings and engines. Davis immediately moved to abandon the takeoff. Closing the thrust levers, he hit the brakes hard while simultaneously selecting reverse thrust on all 3 engines, in an effort to do all he could to bring the massive jet to a stop. As he did so, directly above his head, a number of different master caution and warning lights simultaneously illuminated. Carrier called out, "Jack, your number 3 is acting up." This was becoming more than just a straightforward bird strike. As all 3 engines transitioned into reverse, Holland, from his position over Davis's right-hand shoulder, was heard to concur with Carrier's assessment of the situation, as he called out that they had just lost the number 3 engine. that being the engine slung under the right starboard wing. With such a large number of seagulls impacting the jet simultaneously, it was inevitable that some would be ingested into at least one, if not all, of the aircraft's 3 engines. And by all accounts, the number 3 engine had taken the brunt of the damage. Given the sudden failure of the number 3 engine, hydraulic pressure from its associated number 3 hydraulic system had also been lost, as Holland spotted the needle of its pressure gauge almost instantaneously drop to 0. Amongst other things, the loss of this hydraulic system meant that the aircraft's number 2 braking system was also gone, as was the number 3 reverser, and 20% of the spoilers on the wing's upper surface used to help with retardation under such circumstances. Unbeknownst to the crew at this time was the fact that the number 3 engine had not merely wound down due to the ingestion of seagulls, but rather it had failed in the most catastrophic uncontained manner. With the engine rotating at just over 3,700 RPM, the sudden violent shock of the birds being ingested had resulted in parts of the engine's compressor and a significant amount of shrapnel being physically ejected from the engine core in all directions, subsequently impacting and severely damaging a number of wheels and tyres on the right-hand main landing gear. Bad and all as this was, however, built-in system redundancy would ultimately ensure that braking was still possible through the number 1 braking system. That said, given the aircraft's extremely high weight, pre-departure performance calculations with regard to the execution of a rejected takeoff proved that it could be done from a go, no-go decision speed of V1, provided all of the aircraft's retardation systems were operating normally, which now obviously was no longer the case. Despite the fact that Davis had initiated the rejected takeoff at a speed less than V1, nonetheless, given the obvious damage to the aircraft, stopping before the end of the runway was now going to be a challenge. But the crew's problems wouldn't stop there. The catastrophic manner in which the number 3 engine had failed had instantaneously resulted in its main fuel line being severed, releasing a raw fuel stream of about 150 gallons per minute, which was immediately ignited. Within seconds, the fire warning light for engine number 3 illuminated, accompanied by its associated oral alert. In an attempt to shut down the engine, an effort was made to close its fuel shut-off lever, but it was found to be jammed and physically couldn't be moved. Holland instead quickly shifted his attention to the engine's fire handle and pulled it, an alternative method of closing the fuel shut-off valve while allowing for activation of the associated fire extinguishing agents. Although he recalled never seeing a positive indication that the extinguishing agents had discharged, he and Carrier were of the belief that all necessary actions to shut down the engine had been completed within about 6 to 7 seconds from the time they had noticed its failure. Initially, the crew recalled experiencing a positive rate of deceleration. However, as the rollout continued, all agreed that deceleration reduced to a level whereby they were no longer confident of the jet stopping before the end of the runway. Davis testified that he couldn't recall if the anti-skid had released, and given the rough surface condition of the runway, was unable to comment as to whether the system had performed as expected or not. As if all this wasn't enough to contend with, Davis had another serious problem on his hands. Runway 13 right had no overrun area off its end. In fact, the reciprocal end of the runway, that being 31 left, backed up almost directly onto the perpendicular runway 04 right. In order to protect aircraft using 04 right from the powerful jet blasts of aircraft departing from 31 left, a heavy, very solid blast fence had been erected between the two, which now lay directly in the DC-10's path, as Davis desperately tried to stop. He knew instinctively that a collision with the blast fence would be catastrophic, both for the DC-10 and all those on board. So in that moment, with a stop on the paved surface looking all the more unlikely, he decided that his only option was to attempt a high-speed exit off the runway and onto the last available taxiway, that being taxiway Zulu, which angled off the end of runway 13 right to the left at about a 50-degree incline. With the taxiway fast approaching, Davis aggressively steered the jet to the left, cutting the corner onto the taxiway at a speed estimated to be about 40 knots, the equivalent of 46 miles per hour or 74 kilometers per hour. The aircraft subsequently left the paved surface and started to career across the adjacent grass, But the stress generated by the abrupt change of direction was more than the structure of the main landing gear was designed to withstand. The resultant turning force on the right-hand main landing gear caused it to fold in on itself, allowing the right-hand wing to subsequently strike the ground as the jet continued to decelerate. The centre and left-hand main landing gears also collapsed, leaving the DC-10 with its tail on the ground and nose in the air as it finally came to a stop just short of an airport communication array. With the aircraft now motionless, Holland pulled the fire handles for both engines 1 and 2, with Davis later testifying that he had also managed to close the fuel shut-off levers to both engines before leaving the cockpit. In all likelihood, while still trying to process all that was happening, it was doubtful whether Davis, Carrier and Holland had any real appreciation for exactly how bad things actually were. While being aware that the aircraft's main landing gear had collapsed, what they couldn't have known was that in doing so, as the right-hand main gear folded in on itself, the wing on that side of the aircraft had struck the ground, resulting in failure of the right-hand wing spar. Its failure had further resulted in the fracture of the number 3 fuel tank, causing a massive fuel leak to develop, feeding directly into the fire which was already well developed. Furthermore, as the right-hand wing contacted the ground, what remained of the number 3 engine was displaced inboard, penetrating the wing's lower skin in the area of the number 2 fuel tank and causing yet another leak to add to the crew's woes. Although fire crews had arrived within a minute or so of the aircraft coming to a stop, the blaze proved extremely difficult to tackle due in no small part to the large amount of leaking fuel which was feeding the fire on the right-hand side of the aircraft, much of which had flowed from the immediate crash site through a storm drain and was collecting underground. Within seconds, flames and smoke had surrounded the aft fuselage and had begun to enter the cabin. But amongst the passengers there was no panic, the vast majority of whom were flight attendants who had spent their whole professional lives training for just such a scenario. Although the cockpit public address handset had become displaced during the event, making it impossible for Davis to order an evacuation, the cabin crew on duty, being aware of the imminent danger, took matters into their own hands and, using their own initiative, opened the available exits without delay. The forward left door was the first to be opened, but it was effectively rendered unusable due to the presence of smoke billowing from underneath the aircraft. Moving to the opposite side of the aircraft, the forward right-hand door was opened next. This proved to be a better proposition. The slide deployed, with passengers beginning a rapid but orderly exit. With the rear exits completely unusable due to the presence of fire and huge volumes of toxic smoke, and the overwing exits similarly out of commission, all 128 passengers were forced to evacuate through the one available door at the front of the aircraft. Undoubtedly, on any other day with any other normal cross-section of passenger complement, this eventuality would most likely have had devastating consequences. But if there was to be one positive from the story of ONA Flight 032, it was the fact that, given their training and expertise, all escaped the blazing inferno in record time. When Carrier opened his cockpit side window, he saw an intense fire burning on the right wing. At the same moment, one of the cabin crew entered the cockpit, and with the door open behind her, Davis could clearly see thick black smoke concentrated in the rear of the cabin. With a high concentration of passengers now waiting their turn to evacuate through the forward entry door, Davis, Carrier and Holland all elected to exit the aircraft through the open cockpit windows, using the aircraft's integral escape ropes. Conitster, at the rear of the cockpit, thought it quicker for him to instead head rearward, where he joined the melee of people attempting to leave the aircraft through the forward exit. No one was initially sure whether or not all those on board had managed to escape, but a headcount soon brought the welcome news that all 11 crew and 128 passengers had been accounted for, thanks in no small part to their fortuitous background and speedy, orderly evacuation. Of the total on board, 6 crew and 27 passengers had been injured, but none seriously. The aircraft burned for another 36 hours before the flames were eventually brought under control. By the time it was all over, all that remained of the DC-10 was its tail, its left wingtip, and a pile of charred rubble. Arriving at JFK, the investigation team from the National Transportation Safety Board were confronted with a scene of total devastation. Their search for answers as to what had happened to the crippled jet was to begin on runway 13 right itself, where a wide range of debris appeared to stretch all the way back down the runway from where the DC-10 had come to rest. Just prior to the jet's final resting place, the ground had been scarred with a large number of gouge marks, indicating that at the time the aircraft had left the paved runway surface, of the 10 main gear tires, 4 had been entirely lost and 4 more had been deflated. Further back down the debris trail, pieces of the number 3 engine were found strewn over a considerable part of the runway and adjacent grass, including a large amount of debris from inside the engine's high-pressure compressor. It didn't require a huge degree of investigation work to establish that the number 3 engine had failed, and in a most catastrophic manner. The obvious question now was why. Working further back along the line of debris, which extended for nearly 8,500 feet or 2,600 metres, the telltale signs of a potential bird strike began to present themselves. Close to the start of the debris trail, the investigation team found more significant structural elements, identified as being from the number 3 engine, along with the carcasses of 23 dead seagulls. One of the recovered carcasses had a measured wingspan of 66 inches, or in about 170 centimetres, with the largest birds weighing up to 5 pounds, or just under 2.5 kilograms. Examination of what was left of the number 3 engine suggested that an unknown number of these large birds, perhaps 5 or 6, had been ingested into the fan and pulverised, causing significant damage to a number of fan blades as they did so. The concern now was that if this had indeed been a bird strike, and evidence strongly suggested that to be the case, this kind of fan damage should have been contained and should not have given rise to the catastrophic failure which had obviously occurred. So why had it? Despite the fact that the CF6 engine had been in service now for a number of years, having been certified in the late 60s, if, hypothetically, it had a previously undiscovered weakness which made it susceptible to significant bird strikes, then this needed to be established, and quick. With evidence pointing to a significant bird strike having been the root cause of the accident, the number, size and weight of the bird carcasses found raised some serious questions for the NTSB in relation to current engine certification standards, and whether they were robust and adequate enough for these new generation of large turbofan engines like the CF6. The initial certification test program for the CF6 engine back in 1968 had occurred at a time when the industry as a whole had very little operational experience of these large turbofan engines. Thus, amendments to the existing certification standards at the time were proposed by General Electric and ultimately accepted by the FAA, which retained overall responsibility for regulatory oversight. The test regime set out to prove that the CF6 engine was capable of ingesting birds, hailstones and ice slabs at typical aircraft velocities, without indication of imminent engine failure or the need for immediate engine shutdown. Indeed, there was an expectation that even with the ingestion of larger birds, the engine should still be able to produce a useful amount of thrust, although admittedly an exact figure was never actually stipulated. Evidence from the accident site was, however, now pointing to the fact that in the case of ONA Flight 032, this, for whatever reason, hadn't happened. Could it be that the initial testing program had been underrepresentative of real-world conditions? And if so, was the implication that the CF6 and its various derivatives had an Achilles heel, which heretofore had never been uncovered? The only way to know for sure was to retest the engine under more challenging conditions. With the help of General Electric, the engine manufacturer, 2 test engines were used to simulate the estimated forces experienced by engine number 3 at the exact moment the flock of seagulls had impacted the fan, causing the partial separation of several blades and its resultant unbalancing as it produced maximum takeoff power. Rotating components of these turbofan engines are built to extremely precise tolerances, and when rotating at 3,700 RPM, as was the case when the gulls were ingested, any disruption to this fine balance can result in the generation of immense shear forces. Question now was whether these shear forces were strong enough to literally rip the engine apart. In the end, exhaustive testing had revealed that they weren't. and that even with an imbalance 25% greater than had been experienced by the accident engine, the test engines, although severely damaged, had stayed in one piece, just as the manufacturer had said they would. In one way, had the engine failed these tests, all interested parties, the NTSB, General Electric and the FAA, would have been able to coordinate efforts to rectify the identified problem. The difficulty now, however, appeared to be the fact that there was no problem. Yet without doubt, the accident number 3 engine had succumbed to a catastrophic destructive force, even greater than that which had been reproduced in the test. But how? It looked like it was back to the drawing board. One possible clue to the mystery lay in the remains of the compressor case, which had been recovered from a location at the beginning of the debris field on runway 13 right. It, as well as enclosing the rotating parts of the engine's compressor, is also designed to ensure structural integrity in the unlikely event of the compressor's disintegration. In other words, were the compressor to catastrophically fail at a high rotational speed, this casing is designed to prevent any broken parts from being ejected from the engine's core. Yet upon closer examination, what they realised was that not only had the casing been apparently deformed from within, the bolts holding it together had actually failed as a result of tension loading, suggesting that the damage had been caused by an interior overpressure event, an explosion, for want of a better word. The ingestion of the gulls had caused damage to the rotating fan, which, although massively unbalanced, had supposedly stayed intact. Yet for some reason there appeared to have been a subsequent internal explosion. Again, the question was why. From time to time, the airflow through these engines can be disturbed, for a variety of reasons, resulting in its momentary reversal, meaning that instead of the airflow's normal flow from low pressure to high pressure compressor, a sudden overpressure condition in the high pressure compressor can relieve itself forward, back through the low pressure section of the engine. Such a phenomenon is called a compressor stall, and is usually accompanied by a loud bang, momentary high vibration, flame propagation from the combustion chamber back out through the engine inlet, or indeed a combination of all three. Yet, bad and all as such an event can appear to the external observer, such compressor stalls are actually quite benign and rarely, if ever, result in physical damage to the engine itself. So, that being the case, a compressor stall was, in all likelihood, not the root cause of the problem. It had to be related to something else, some other explosive material which somehow had found its way into the internal workings of the engine and subsequently detonated. Although both the NTSB and General Electric were in agreement as to what had likely happened to engine number 3, that being an internal detonation which ultimately blew it off the wing, the likely cause of this explosion was in dispute. From the manufacturer's perspective, it believed that the most likely cause of the explosion had been the introduction of excessive amounts of fuel into the engine's combustion chamber, as a result of debris from a burst tyre on the right-hand main landing gear striking the number 3 engine, penetrating the engine cowl and damaging the compressor casing, whilst at the same time severing the main fuel line, thus introducing the excess of fuel which subsequently exploded and destroyed the engine. Although not denying the occurrence of a bird strike, they were sceptical that such a strike could have caused such significant damage to the fan blades, and as such they persisted with the hypothesis that it was instead tyre debris from the failed tyre of the right-hand main landing gear which had actually been ingested, causing the damage. The subsequent ingestion of birds was thus, from their perspective, considered to have been a completely standalone, coincidental event. In proposing the plausibility of such a chain of events, it was clear that General Electric was attempting to exonerate their product by virtue of the fact that no engine could be designed to reasonably withstand such abuse, and therefore the entire event had essentially been a case of incredibly unfortunate timing and sheer bad luck. The investigation team from the NTSB were, however, unconvinced, believing that such a hypothesis simply wasn't credible, meaning that for them the search for the cause of the explosion would continue. In fact, with publication of their final report, this hypothesis was considered to be so far-fetched that it wasn't even mentioned. In contrast, what the final report did actually make reference to was a piece of engine cowling which they believed had made contact with the tyre of the number 10 wheel, that being the right-hand wheel of the centre main landing gear, the implication being that this contact occurred after the engine had already begun to disintegrate and not before, meaning that pieces of engine number 3 had, in their opinion, caused the damage to the aircraft tyres, rather than the other way round. The NTSB's attention was instead drawn to the results of later tests which had been conducted by the manufacturer. Test results which they believed had revealed an interesting and surprising possibility. This being that the consensus of an explosion within the engine had actually been caused by the ignition of a significant concentration of dust particles. It was their consistent belief that the bird strike itself had been the catalyst which ultimately fractured a number of the blades in the engine's fan section. The loss of these blades would have had the effect of throwing the engine's central shaft out of balance. Thus, the fan and compressor discs would subsequently have been rotating out of true, with a pronounced wobble, if you like. By design, these components are engineered to extremely high tolerances, so as to ensure smooth flow of air through the engine. Thus, they proposed that any imbalanced rotation caused by the central shaft being out of true would have most certainly resulted in near constant contact between the tips of the fans and compressor blades with the surrounding abradable rub shroud. On any given day, this interior easily worn lining of both the fan and compressor casings is designed to rub off when contacted by the respective blade tips, thus preventing any damage. Such contact routinely occurs, as these rapidly rotating discs retain gyroscopic characteristics, meaning that they tend to resist change in their plane of rotation. Thus, any sudden upset in flight due to turbulence, for example, will tend to result in movement of the engine structure itself, whilst the internal, rapidly spinning fan and compressor discs will, because of this gyroscopic tendency, try to remain in place, resulting in momentary contact between the two. The important takeaway here being the reference to momentary contact. In the context of ONA Flight 032, however, when the fan was subjected to this severe imbalance, the resultant wobbling of the engine's central shaft would, they believe, have resulted not in any momentary contact with the blade tips and the abradable shroud, but rather almost constant contact. And under these circumstances, General Electric's own tests had revealed something which heretofore hadn't been appreciated. Under such circumstances, as the blades continuously ground against the abradable strips, the epoxy resin from which the strips were made would scrape away in the form of a fine powder. This powder would travel rearward with the flow of air passing through the engine until ultimately entering the high-pressure compressor. Lest anyone believe that the possibility of a dust particle explosion completely destroying a large jet engine is somewhat unrealistic and fanciful, spare a thought for the victims of the Benijou colliery explosion of April 26, 1942, where gas and coal dust suspended in the air ignited, killing 1,549 miners. Or the two separate grain silo explosions of December 1977 in Louisiana and Texas in the United States, collectively killing 56. Or the Kunsan explosion of August 2, 2014, again in China, where ignition of very fine suspended metal particles resulted in the deaths of 146. The list goes on, with evidence compelling. What the manufacturer's tests had revealed was that the particular epoxy resin used for the rub strips on this particular engine had a tendency to ignite more explosively and at a lower temperature than other materials used for the same purpose. Indeed, what was also noted was the fact that a specific range of fan imbalance levels was required in order to produce a flammable concentration of dust in the high-pressure compressor. A fan with less damage would not produce enough dust to permit auto-ignition, whilst a fan with substantially more damage would produce too much dust, also preventing ignition, most probably the very reason why this phenomena had not been detected previously. The damage to the jet's number 3 engine had apparently fallen right in the sweet spot, with its central shaft wobbling just enough to wear away the shroud material at the correct rate in order to produce the fuel-air mixture that would auto-ignite under the specific conditions found inside the high-pressure compressor at that very moment. The NTSB believed that the explosion of the powderized rub shroud material was sufficient by itself to cause the catastrophic failure of the high-pressure compressor casing, resulting in disintegration of the engine. Not surprisingly, however, given their previous interpretation of events, the manufacturer General Electric didn't entirely agree, given the fact that a dust particle explosion under the circumstances was not only possible but probable. They conceded that such an event would most definitely damage the compressor casing, but disagreed that the explosion in itself could have resulted in total structural failure, again insisting that simultaneous external damage to the casing from flying tyre debris must have pushed it over the edge, and so the two parties agreed to disagree. All of this being said, a number of questions remained, not least of which was the reason behind the crew's inability to stop the aircraft within the given runway length. The final report made little references to why, but given the aircraft's near maximum takeoff weight, the investigation team ultimately concluded that multiple tyre failures, the loss of reverse thrust on engine number 3, along with the failure of its associated hydraulic system, and the prevailing wet surface conditions on the runway at the time, had all combined to play their part. Although the cockpit voice recorder had been destroyed in the post-accident fire, the video footage captured by Ben Conister had allowed investigators to reconstruct the crew's actions, and on that basis they had determined that they had done everything right to ensure, as best they could, a safe outcome. They ultimately praised the flight crew for their conduct during the emergency and post-crash evacuation, including Davis's decision to quickly abandon the takeoff and his efforts to avoid a collision with the blast fence once it became clear that a runway overrun could not be averted. In addition to their investigation into the aircraft itself, the NTSB also took a look at the control measures in place at JFK International to mitigate against the potentially dangerous movement of birds into the active flight strip. Runway 13 right had not been in use for many hours prior to the accident, and as such, given its proximity to the waters of Jamaica Bay, it was not surprising that many birds had claimed it as their own. Such a scenario was, the investigation team believed, completely predictable, yet no one in the tower had seen it necessary to initiate a runway inspection or board patrol before reinstating the runway's operational status. JFK's bird problems were well known, with a noticeable increase in bird encounters being recorded year on year between 1974 and 75. This had resulted in greater investment in resources, including more dedicated control personnel and associated equipment. But, with the Port Authority having admittedly made such tangible investments, it sadly appeared that the intangibles, such as procedures and discipline, had regrettably not kept pace. As a direct result of the accident of Overseas National Airways Flight 032, several safety changes were made in many related areas. General Electric replaced the epoxy resin rub shrouds being fitted to their CF6 engines with less flammable aluminium, while the FAA mandated that other manufacturers do the same. In addition, the FAA were to chair a series of meetings aimed at revising and updating standards for aircraft tyres, wheels and braking systems, which would ultimately culminate new regulations being issued some years later in 1979. With regard wildlife control measures at JFK, the Port Authority launched a campaign to remove features from near the airport which they believed would likely attract birds, with ATC being mandated to initiate a bird sweep anytime a runway's status is changed from inactive to active. And lastly, in order to comply with modern regulations regarding clear areas for potential runway overruns, the infamous blast fence, which had existed on the day off the departure end of 13 right, was completely removed. Aircraft using runway 04 right are nowadays protected from jet blasts by sheer distance alone, with the threshold of the reciprocal runway 13 left having been moved about 3,300 feet, or the equivalent of about 1,000 metres further to the west. Ultimately, the disagreement between the NTSB and General Electric over the fundamental cause of the engine's disintegration was never resolved. But it would have to be said from the perspective of the impartial observer that the NTSB's proposal surely presents a more probable outcome. Although the engine manufacturer presented evidence of what it claimed was hard body damage to the fan blades prior to the seagull's ingestion, its claims that these birds could not have caused such severe fan blade damage remain somewhat sceptical, At the time, the CF6 series of engines was first certified back in 1968. As I've already said, there was virtually no understanding of how high bypass turbofan engines with large fans would behave following the ingestion of large numbers and sizes of birds. At the time, for these new engine types, regulatory requirements simply hadn't caught up, and indeed no additional unique testing was mandated above and beyond those which already existed. Evidence pointed to the fact that the number 3 engine had in all likelihood ingested as many as 5 to 6 seagulls, the average weight of which being 3 to 4 pounds, that being around 1.5 to 2 kilograms in weight, with one specimen weighing in at a massive 5 pounds or nearly 2.5 kilos. Such a scenario had never been tested for, and as such, the available evidence did not clarify on what basis General Electric had concluded that an event of such magnitude could not possibly have caused the observed flambe damage. Add to this the likelihood of a catastrophic tyre failure independently occurring within a fraction of a second of a significant bird strike, is, to say the very least, a wild coincidence if proven, but an extremely suspicious one if not. As such, the final report would go to print without any reference to General Electric's hypothesis whatsoever. Today, in accordance with regulations introduced in 2007, high bypass turbofan engines such as the CF6 and its modern derivatives must all be capable of withstanding the ingestion of multiple birds weighing up to 5.5 pounds in weight, the equivalent of 2.5 kilos, with any resultant thrust loss not exceeding 50%. As the investigation team set about their work, for those involved in the accident, life continued to move on. Just 2 days after the accident, most of those who had been on Flight 032 boarded a new DC-10 which had been leased by ONA at short notice, and proceeded to Saudi Arabia as per the original arrangements. In retrospect, however, many ONA employees came to see the accident of 032 as the beginning of the end for the company. With the memory of a DC-9 crash back in 1970 still relatively fresh in the memories of many, less than 2 months after this accident, in January 1976, ONA's only other DC-10 was also lost in a non-fatal landing accident at Istanbul, while on lease to Saudi Arabian Airlines. Despite trying to push on and purchasing a further 3 more DC-10s through the years of 1977 and 78, in October of that year, the company's owners made the difficult decision to shut the operation down. In an ironic twist of fate, 2 of these 3 remaining DC-10s were also lost in separate crashes over the next 5 years. The first, Spantex Flight 995, crashed on takeoff from Malaga in Spain on September 13, 1982, with the second a non-fatal runway collision at Anchorage, Alaska on December 23, 1983. While operating as Korean Air Flight 084, an accident which I've extensively covered here on the channel. Only the 5th and final DC-10 survived, eventually remaining in service with FedEx until being decommissioned in 2022. In conclusion, it's fair to say that the story of Overseas National Airways Flight 032, despite everything, could have been a whole lot worse. Had the same events happened to a DC-10 full of regular passengers, comprising of children, seniors and the disabled, the likelihood is many would not have got out alive. Yet in truth, the loss of the aircraft and the ultimate understanding as to why contributed to a legacy whereby engine design and certification is now more robust and realistic as a result, and that is to the benefit of us all.